Next, let's look at the algorithms library that is part of the STL collection. We include the algorithm header in order to use this library. And I'm also including vector because I want to be able to work with vectors. Here's our main function. And in this main function, I define an integers array and I put some seemingly random values. Some are positive, some are negative inside this array. And I'm creating a vector of integers of the values in this array. I'm calling that vector numbers, and to its constructor, I'm passing two parameters. One is a pointer to the beginning of this array, and the other is the pointer to the end of this array using the functions std colon begin colon colon begin and std colon colon end from the STL library. Now, I have defined a variable val and set it equal to 751. I'll use this later on. This value 751 does not occur anywhere in this array, by the way. Next thing I'm going to do is to sort this vector using the sort function from the algorithm library. But before we do that, we display all the elements in the stored in the vector using the same kind of for loop that we've seen before when we studied vectors. Then I call the sort function from the algorithm library. And what I'm passing to it are three parameters. One specifies where the range of values that need to be sorted start and end. Okay, so this is one element past the last element that we want to be included in sorting. We want the entire vector to be sorted. That's why I have called numbers.begin and numbers.end and passed those values as the first two parameters. The last parameter to the sort function is a comparison function. And in this case, I'm using a template function intcomp with a template type parameter of int. It's defined right here, just above main. Now, you'd understand that most sorting algorithms are based on comparisons and they pick pairs of values from the collection or data that they're trying to sort. And there's a pairwise comparison that sees if there's a need to swap the two values or they are stored in the correct sorted order. So int comp is a comparison function that is going to return a bool, which is going to be either a true or a false. And it should return true if the first parameter should be before the second parameter in the sorted order. Now I'm doing return j less than I, which is going to return true if the second element is smaller than the element, smaller than the first element. Uh, and I'd like you to think about what kind of sorting this might result in, and we'll see the result shortly once we run the code. But think about what this might be doing. And after the call to sort, we display the values in the vector once again using the same kind of for loop. And then we are working with a vector of strings. Let's comment out this part of the code and see the sort function in action in the terminal. We switch to the terminal. I clear the terminal. I compare while the file's just fine. We run it. And before swapping, you see the values in the random order in which we initialize them. And after sorting, you see that the numbers are sorted in descending order. I don't know, let's see what happens if we change our comparison function. So let's say, what if I return I less than j instead of j less than I? What happens then? Save the program. Let's switch to the terminal, compile the program again. And now you see that these numbers are sorted in ascending order. So that's the role function. You can use it to tweak the way you want your numbers to be sorted. Let's switch back to code and see the rest of the program. I'm going to uncomment it. And you'll see that I've declared a vector of strings named names, and I've stored a few strings in it. And then I've displayed the contents of that vector. I call the sort function. The first two arguments are very similar, just as we had done numbers.begin and numbers.end. I've got names.begin and names.end. And the third parameter, the template function, I am initializing it with the template parameter value of std colon colon string. So it's going to still use this int comp function, but p is going to be replaced by string. After this call, we display the value stored in that vector of strings and the program ends. So let's see what happens when we compile and run this program. I compile the program, compiles just fine. I run the program and we see that before sorting, these were the names: John Doe, Jane Smith, Alice Johnson, and Bob Brown. And after sorting, they are in alphabetical order: Alice Johnson, Bob Brown, Jane Smith, then John Doe. And of course, if we switch back to code and we go to the comparison function, and instead of I less than j, we do j less than I, then you would hope that the sorting order should change. So let's see what happens. Now, sure enough, the elements are sorted in descending order. So that is how you might use the sort function from the algorithms library. You might be wondering what's the purpose of this int variable val. It was never used in the program. And the reason I had defined it is what I was trying to do is to use it with another function from the algorithms library. And that's a function named std colon colon find. And the find function, it returns to you an iterator and it tries to find a value inside a container. So I'm trying to find a value in the numbers collection, starting at the beginning and all the way to the end. So I want the find function to look for a value throughout that vector. And the value that I'm looking for is in the variable named val. So what this function returns to us is an iterator. And since we are dealing with a vector of int types, this is going to be type vector int colon colon iterator. That's going to be the type of the iterator returned by the find function. Now, the function might be able to successfully find that value in the vector, or it might not find any occurrence of that value in the vector. So what we need to do is to compare the value of this iterator against numbers.end. If the iterator is not equal to numbers.end, that means that the value was actually found in the vector. So I can say std colon colon cout val was found in the vector. But otherwise, if the iterator indeed is equal to numbers.end, I might say that val was not found in the vector. And then I could do a new. So let's see what happens if we switch to the terminal and compile and run this program. There we go. We run the program and it tells us the 751 was not found in the vector. So let's see what happens if we change the value to 75, which is a value that does exist in the vector. So I change val to be 75 instead of 751. And then we switch to the terminal and compile and run the program again. Compiles just fine. When we run it, and it says 75 was found in the vector. So find is a function that you can use to look for values in STL containers. You could also use it to find values in arrays, and it works with all different data types. So find and sort are two examples of algorithms that are implemented in the standard template library, and they work on the built-in arrays in C++, and these could be arrays of the predefined data types like int and float, could be arrays of uh, custom defined classes that you create, or they also work with the STL containers. So very useful thing to know. I also have this program that sorts a vector of structures of type person. I've defined that struct over here, and I've created a vector of instances of this structure. And I apply the STL sort algorithm to sort the elements in this vector. And I'll let you look through and run this program, experiment with it yourself.